Hey everybody, so in this video I'm going to be talking about diagnosing computer power supplies open with the cover off. This is something that should only be done by personnel who are well versed in electronics and working around high voltage equipment. This is not something that you should even think about doing if you are not experienced in this kind of field. I've been working on computers for many years, and also I have a background in computer electronics, computer engineering technology. I also have a background in electrical engineering technology. So I'm very familiar with the hazards that are inside of these units. Now, there is a reason that most computer technicians, when they find one of these not working, they just replace them. And they do have a warning label on them warning you of what's inside, and that's there for a reason. But provided you know what you're doing, you can actually repair these things. And in some rare cases, that involves troubleshooting the unit with the cover off, because you need to access components inside to check voltages and things like that. So again, not something most people should do unless you are very, very well versed in this field. So this video is just for educational purposes only. I will not be responsible for any injuries from repeating anything done in this video. That being said, let me go and discuss the safety precautions that I am taking for this procedure. Number one, these are high voltage gloves. They're rated for 1 kilovolt. Now, when I'm working inside this power supply, you're going to see in a moment, I'm going to still be acting like I'm not wearing these. Basically, I'm not going to rely on these. They're just there for an added level of protection. So high voltage gloves, they're a must have when working in something like this. It's an added level of safety protection. Next, safety glasses. In the event there is a flash in this unit and an electronic component explodes or whatever, you do not want that going in your eyes. Now, of course, these are not like arc welding glasses. They're not intended for that purpose, but the purpose of these is to protect stuff from going into your eyes. Next thing is this device right here, which I created in a recent video. This device here acts as a ballast using an incandescent light bulb, a 60-watt incandescent light bulb, as a ballast. It puts this in series with the live supply to, for example, right here. So that in the event there is a short circuit in this power supply, it will prevent your circuit breaker from tripping and will also limit the amount of inrush fault current to this unit. Now, as I'll be discussing in a moment, there are high voltage capacitors inside this unit. So it will not, this right here will not prevent you from seeing a flash in the event something goes wrong. But this will help limit the amount of current that is inrushed from the main supply. The next thing is a decent quality digital multimeter. Preferably with one that has safety designed probes like these here, where only the tips are bare metal. Everything above these tips is insulated. So when you're working inside a device where things are tight, you have conductors everywhere, the chances of accidentally bridging a connection and causing a short circuit are reduced by having leads such as these here. Now, while the cheap multimeter from, let's say, Harbor Freight Tools will be good for a lot of things, I would not recommend a cheap multimeter for this. I recommend a decent quality Fluke or just a decent quality brand like this Klein meter. So, that being said, let's go and have a look at the power supply. Okay, everybody, so here we're looking at this Bestec ATX 312Z power supply that I recently had worked on. I featured this in a recent video where I put it side by side with another ATX 312Z unit. I was showing the progression of the infamous tan glue that's in some of these units, and this one here has operated in some hot temps over its lifespan, so the glue in this one has darkened, and in some areas it got really dark and got corrosive and probably conductive as well. So I did not test this unit before I recapped it. So what I did is I had scraped all the glue mess off of the high voltage components. Now of course this unit's not powered up right now, it's not receiving power. I scraped the glue off the high voltage components, gave this thing a recap, at least the big caps over here, and also had to recap the primary in this one, which is kind of unheard of. I've only had to do it like 2 or 3 different units over the years I've been working on these things. So this capacitor, this is one of 2 that came out of this unit. You can see it's bulged on top, and that is a Panasonic cap too, so that's really insane. So this unit must have operated in some pretty hot conditions, and the problem with this unit is now the only thing it works on is the 5-volt standby rail. It does not power up otherwise. It doesn't even try to. Now technically it does try to. The supervisory chip does attempt to start the unit, however it gives up after about half a second. And I think I've ruled out the culprit as an optocoupler down the side there, which sends a signal from the supervisory chip to the PWM chip to turn on the main switcher over here. Now again, this unit is not yet energized. Before I energize it, I'm going to talk about a couple more things. First and foremost, if your hands are shaky, either due to being nervous or due to a medical condition, do not proceed with this. If you're just not confident, you're uncomfortable, do not proceed unless you can work up the confidence to work on something like this, because when you're nervous and you're shaky, that's when you can really mess things up and have an accident. Now of course we don't want accidents, we try to avoid them, and that's also why we have this personal protective equipment, these gloves, the safety glasses, and also I'm going to be placing on my headlamp, which hopefully won't over brighten parts of the video, but if it does, I'm sorry, too bad. I gotta see what I'm doing in here. But what we're going to do is we're going to power this up, and I'm going to show you the high voltages that are present inside of a PC power supply. So that being said, let's go ahead and power on the meter. And this is like my second or third reshoot. It's my third reshoot, because in the previous shoot my hands were almost over the meter the entire time. So hopefully this time we'll get everything on camera. Alright, so what we're going to do now is we're going to power this thing up. Now I should note this unit is actually jumpered to power on, however it's not going to power on, it's going to remain in standby. So I'm going to go ahead and power this up. So you see how the bulb briefly pulsed there for a moment. Alright, so as I mentioned at the beginning of this video, the cover on computer power supplies warns you of high voltage. This is what they're talking about right here. As you can see, we have 334 volts DC in this unit. This is straight across, or almost straight across, the bridge rectifier. The primary heatsink is actually tied to the negative of the bridge rectifier. So the way this works is you have, for example, in North America, you have 120 volts AC coming in through here. That passes through some filtering components and onto the PCB, runs through this NTC thermistor, which acts as an inrush current limiter. And then you have these yellow wires here. This first wire, it travels in through here to a switch, and in North America or anywhere where the voltage is 115 volts, the switch is closed, which activates what's called a voltage doubler circuit. It uses this bridge rectifier and these two caps as a voltage doubler. So What's happening here is, for example, if I measure from the heatsink to the power supply case, you'll see that we have negative 167 volts DC. And for example, if I measure from the positive of the bridge rectifier, you can see we have positive 167 volts DC. So more or less what's going on here is the rectifier is capturing the V peak values of our AC sine wave. So 120 volts or 230 volts AC, that is basically what's called a RMS value. Now that's actually like an average. It's not the peak voltage of, let's say, that supply. The bridge rectifier captures the peaks of that, and because it's a full wave rectifier, it captures both the positive and the negative peaks of the complete sine wave. And in the case of using the voltage doubler, it actually doubles that from roughly 170 volts to 340 volts. So there you go. So for example, when we test components inside of this unit, if we want to check voltages inside of this unit, anything that's over on the primary side, we're using this heatsink here as our negative connection for the meter to get an accurate reading. So for example, what I'm going to do now is I'm going to check the voltage on one of these diodes down here. You can see we have about 16 volts there. So in a computer power supply, the 5 volt standby rail actually generates two voltages. It generates your plus 5 volt standby, which for example, we'll use the case ground for this because the 5 volt standby is not part of the high voltage section. You can see there's your 5 volt standby rail. And it also generates that auxiliary power supply that we saw just a moment ago, that's 16 volts. That's used to drive what's called a PWM controller, or PWM chip, which is over here in the primary section. So the 5 volt standby rail supplies 5 volt standby power to your computer's motherboard. It also provides power to the supervisory chip, which is what actually receives the power on signal from your motherboard and commands the unit to turn on. What's going on with this unit is when the supervisor chip sends out a signal on the FPO pin, which is an active low, meaning it pulls at the ground to light up the LED inside of the optocoupler. What's going on is this optocoupler is defective, or it's faulty. Because what's happening is on the other side of the optocoupler you have a phototransistor, which is supposed to lower resistance down to basically next to nothing. More or less it saturates and it allows current to flow through it like a switch. That's not happening here, and therefore this PWM chip is not seeing this auxiliary 14 to 15 volts on its VCC pin. Therefore it's not powering up and powering up the power supply. So what I'm going to be doing later on in a different video is I'm going to be troubleshooting this thing, and hopefully that gets this unit up and running. But again, this is show for example between your positive of the bridge rectifier and this heatsink, which is tied to negative. You have 334 volts there. Now I'll show you what happens when this unit loses power. So what we're going to do now is I'm going to place this lead here so we get it to stay put. Okay, now I have a hand freed up. Alright, so I'm going to go ahead and probe our positive on the bridge rectifier. So again, there's our plus 167 volts. There's our negative 167 volts. Now I'm going to stick it back on the bridge, the plus of the bridge. Okay, so now watch what happens when I turn off the switch. So you see how the voltage kind of spiked up there to close to 300 volts. And you can watch the unit discharge. And there you go. So I'm going to start this up. And you can see we have that negative 164 volts or 165 volts between the primary heatsink and ground. Watch it discharge. So yes, you definitely use caution working inside of these things. If you're ever troubleshooting these with the cover off, there are high voltages present inside of these units. Over 300 volts DC is definitely dangerous. But sometimes, as a measure of troubleshooting a power supply, if you're into advanced electronics repair, sometimes removing this cover is just kind of a necessary evil, because you got to get your multimeter in there to check voltages on specific components. Basically, I have checked to verify that we have 5 volt standby, which we know that works, but we also have our auxiliary supply. I have ruled out the supervisor as being faulty. It works fine. I think our optic oscillator or optocoupler is possibly faulty. Anyways, that's it for this video. Those are some things to keep in mind should you ever decide to work on one of these units with the cover off. First and foremost, if you are not confident in this kind of work, don't do it. Just don't do it. Now, if you are knowledgeable of this equipment, you're knowledgeable of working around high voltages and the hazards that are in place in these things, then sure, go for it. But you definitely have got to be careful. So again, high voltage gloves, safety glasses, a headlamp if possible, that way you have a flashlight on your head, you don't have to hold a flashlight when looking inside these things. Having a good meter like this Klein Tools meter here, and having a good current limiting ballast on your main supply. So anyways, hope you enjoyed this video. Thanks for watching.